Let's talk about antiderivatives or indefinite integrals. This is an introduction to integrals, and this is how we start the integration process. Our objectives for today is to use the power of x formula to find indefinite integrals, to apply properties of indefinite integrals to find certain indefinite integrals using the power of x formula in combination with additional integration formulas. We have been learning how to differentiate. We want to go backwards. When we have the derivative of a function, the process of finding the function itself is called antidifferentiation or antiderivative. And the formal definition of antiderivatives is as follows. Suppose that uppercase f prime of x is equal to lowercase f of x, then uppercase f of x is the antiderivative of f of x. We write it as follows. We say squiggle, indicating anti-differentiation or integral of f of x dx is equal to uppercase f of x. We say that f of x is the integrand and d of x is the differential. The process of finding the antiderivative is also called integration. The function that results when integration takes place is called the indefinite integral, or more simply is just integral. If you keep thinking about reversing the process of differentiation, it's going to be a little bit harsh to learn integrals. And luckily we do have formulas to help us. But let's first understand where it came from. Now remember, the differential variable should be the only variable in the integrand, meaning if the function is in x, then you should have dx. If the function is in y variable, then you should have dy. The first example, we want to show that 3x squared plus 3 is an antiderivative of 6x and find two other antiderivatives. Basically, we have the derivative 6x and we want to prove that the original function was 3x squared plus 3. That means if we differentiate the original function, we should get 6x. This is basically what it is. So let's try to differentiate 3x squared plus 3. So we have 3x squared plus 3. This is basically the function f of x. Then we want to find f prime of x. F prime of x is equal to 6x plus 0, or simply 6x, which is equal to f of x, which is we have here. So because we know the derivative of the function, we have f of x. The antiderivative is this given function right here. And because we have this constant, I can come up with more antiderivatives for this function. Simply, I can say another antiderivative is f of x is equal to 3x squared minus 5. Because if I differentiate this function, I will get 6x still, because I have a different constant. I can say another antiderivative is f of x is equal to 3x squared plus 10, or even 100. And I will be correct, because if I differentiate this function, I will get 6x. So f of x is still an antiderivative for 6x. This will lead us to the following theorem. So because we said if we have f of x is equal to 3x squared plus 5, or f of x is equal to 3x squared minus 5, or f of x is equal to 3x squared plus 100, all of these are antiderivatives of the function f of x is equal to 6x. So because you see here we have different constants and the answer is still the same, we still have f of x as an antiderivative of f of x, we can come up with this theorem. The theorem says, suppose that f of x is an antiderivative of lowercase f of x, then uppercase f of x plus a constant, where c is a constant, is also an antiderivative of f of x. So basically, to find more of these antiderivatives, we just add different constants to the antiderivative function, and that will be correct. So basically, this is what the theorem says. All right, let's look at this example. If you have the derivative f prime of x is equal to x cubed, We want to find f of x. So we want to go back and find the antiderivative of f prime of x. To do that, let's think of what could have made this function. What function I can find the derivative of in order to get x to the third? I can begin with saying that f of x could be equal to x to the fourth. I know that I will get f prime of x is equal to 4x to the third power. But I don't have this 4 right here. So to remove this 4 from here, I will need to divide by 4 in the original function. So when I find the derivative, this 4 is going to be canceled with that 4. So let me find the derivative of this function. So I'm going to say this is f prime of x is equal to 1/4 goes out, and then I have the derivative 4x cubed. So the answer is 1/4 will cancel with that. So the answer is going to be x to the third power. And I found the antiderivative of that function by trial and error. I can find a general antiderivative of the function by adding a constant to that. So we're going to say the antiderivative is f of x is equal to 1/4 x to the fourth power plus c, and that will be an antiderivative for the function f prime of x is equal to x cubed. So this process is kind of dreadful, and if you keep following this process, it's not going to take you anywhere. To write that formally using the notation that we just learned, we say, remember this notation, a squiggle, f prime of x dx is equal to f of x plus c. To write that down using the functions that we have, we're going to say integral of x cubed dx. Notice how the integrand variable and the differential variables agree. Xx equals the antiderivative that we found, 1/4 x to the fourth plus c. This process is kind of hard when you think backwards, but luckily for us, we have a simpler formula to follow so we can get to the answer faster. We don't need to complicate things that way. We can just rely on that formula and we will be done. So that formula says, and it's called the power of x formula, the integral of x raised to any power dx is equal to x to the n plus 1. We add 1 to the power, divide by the new power, and add a constant. And that works for all n except for when n is equal to -1. We have a different formula for that. So using the previous example, if I have f prime of x is equal to x cubed and I want to find f of x, then basically I will find the antiderivative of this function, and that will give me the function f of x plus c. So to apply that formula, I will say, okay, the integral of x to the third power dx is basically equal to, this formula tells me to add 1 to the power and divide by the new power. So I will have x to the fourth over 4 plus c, which is similar to saying 1/4 of x to the fourth plus c. They are similar, and you see how easy that is using this formula instead of relying on trial and error. Let's do another example. We want to evaluate the integral of x to the -1/2 dx. X to the -1/2 dx is equal to, the formula says that I should add 1 to the exponent and divide with the new exponent. So that is x to the -1/2 plus 1 over -1/2 plus 1 plus c, don't forget plus c, which is equal to x to the 1/2 positive over 1/2 plus c. Let me make this a little bit neater. Here is a denominator of the denominator. It becomes a numerator So that will be 2x to the 1/2 plus c. That's not a sign. And to make it a little bit more neater, we're going to say this is basically 2 square root of x plus a constant. Let's evaluate different integrals. So in this case, we have a cube root. We don't know what the integral of the cube root is, but we know if we turn that cube root into a power, so this will turn into, this is the cube root of x dx. It's going to become integral of x to the 3rd power dx, which is basically equal to, I add 1 to the power and divide by the new power plus a constant. So that is x 1/3 plus 1 over 1/3 plus 1 plus the constant. So this becomes x to the 4 over 3 over 4 over 3 plus c. Again, I can take this denominator and turn it into a numerator because it's a denominator in the denominator. So this will become x to the 4 over 3, and here is the 3 over 4 plus c. I can keep it like that, or I can turn it back into a radical. I'm going to turn it back into a radical. So this will become 3 over 4, and then cube root of x to the 4th plus a constant. And that will be the final answer to that integral, or it will be the antiderivative of cube root of x. Let's look at this one. So we have the integral of 1 over x to the 2nd power. I have to bring this up to the numerator to deal with it because the only formula I know is the power of x formula. So I will try to use that formula. So the first step is to turn this into a numerator. I know if I have a power in the denominator, I can bring it up into the denominator with a different sign. So because it's positive, I can bring it up using negative dx. And now to find the antiderivative of x to the -2, I'm going to use the power of x formula. So this will be x to the -2 plus 1 over -2 plus 1 plus a constant, which is equal to x to the -1 over -1 plus c. So this will be -1 over, and I'm going to bring x to the -1 to the denominator with the opposite sign of the power. So that will be x to the +1, but I'm not going to write it down, plus c, and that is basically the final answer, or the antiderivative of 1 over x squared. It is going to be helpful to know some integration formulas. The first formula says if you integrate 1 dx, it's going to give you x plus c. If you have a constant, you can take the constant out of the integration and then integrate as normal. If you integrate in addition of functions, you can integrate each function individually and then add. And here is a new formula. The integration of the exponential function, integration of e to the x dx, is basically e to the x plus c. If you have a constant, you can take it out of the integral. And if you have a coefficient for the exponent of the exponential function, then the integration is going to be, the b came out, and then you divide with the coefficient of the exponent of the exponential function and put the exponential function as it is, plus c. The integration of 1 over x, or x to the -1, dx is basically log of x plus c. So keep these integration formulas in mind. Put them on a piece of paper and keep them in front of you all the time because we will be using them a lot. Let's see if we can evaluate all of these integrations. The first integration is we have integration, find the integration of 4 dx. We know if we integrate a constant, we can bring the constant out. So this is basically 4 integration of dx. Remember, there is a 1 here. And we know that the integration of that is basically x plus c. So we can say this is basically 4x plus, we're not going to say 4c because 4c is still a constant. So we're going to just write c, a constant c. So this is the first part. The second integral says we need to find the integral of 8x to the 5th power dx. We know that if we have a constant, we can bring it out. So we're going to say this is 8 integration of x to the 5th dx, which is equal to 8 times x to the 6th power divided by the new power plus c. And then you can simplify this into 4 over 3 x to the 6th power plus c. And the last one, we want to find the integration of x cubed plus 4x. We can find the integration of each one of these and then add them at last. So this is equal to the integration of x to the 3rd power dx, don't forget that dx, plus the integral of 4x dx. So now we find the integral of each function individually and then add them at last. So the integral of the first one is x to the 4th power over 4 plus c. I'm going to name it c1. And then plus, I can take the 4 out. The integral of x is x squared over 2 plus c2. I can now here simplify, and I can rewrite this as x to the 4th power divided by 4 plus 2x squared plus c1 and c2 will give me one constant, c, and that will be the final answer. Let's look at this example. Example 6, evaluate the integral of 3x plus 2 times x squared minus 2 dx. Notice here that we have multiplication. We have no rule for multiplication when it comes to integrals, so we will need to actually multiply this out and turn it into a polynomial so we can integrate each term individually using the power rule that we have learned. So to do that, I'm going to multiply these out. You can use the box method in order to multiply these terms. You have 3x plus 2 and you have x squared minus 2. So you will have 3x cubed. X times 2 is 2x squared. Negative 2 times 3, negative 6x. Negative 2 times 2 is negative 4. So the answer will be integral of 3x cubed. And then I'm going to add like terms together if there is any. I don't have 2x squared minus 6x minus 4 all dx. So I'm going to integrate each term individually and I will apply the rules immediately. So instead of writing it out, I can just skip it, or if you're not comfortable, you can write it down first. So integral of the first term, I can pull the 3 out of the integral and keep x cubed. So I'm going to say 3 integral of x cubed dx, plus I can pull the 2 out, integral of x squared dx, minus the 6 out, integral of x dx, minus 4 out, integral of 1 dx, or x to the 0 power dx. And now I'm going to do the integration. So this is 3. And then to do the integration using the power rule, I'm going to add 1 to the power, divide with the new power. So x to the 4th divided by 4. I'm not going to write the constant here because we understand all of these constants are going to add up to the end to one big constant. So I will keep it that way. So this is plus the 2 out, x to the 3rd power divided by 3, minus 6x squared divided by 2, minus 4x, and then plus c. You can do some cleanup here, so you can say this is 3 over 4x to the 4th, plus 2 over 3x to the 3rd, minus 3x squared minus 4x plus c, and that will be the final answer. And here's another example. We have subtraction and we have the x in the denominator. Remember, we don't have a rule for that, so we need to bring it up and turn it into a power, although it's going to be a negative power, but that's okay. Remember, we can't integrate if the power is x to the negative 1. Remember, n has to be anything but negative 1. We have, though, a formula that says the integration of 1 over x dx is basically log of x plus c. So we're going to use that formula in this case. So to find this integral, this is equal to, the 3 can come out, and that will be the integral of x to the negative 2 dx. minus the integral of 1 over x dx. I'm going to keep it that way because we don't have an integral for a power that is -1, and the formula that we're going to use is this formula. So now I'm going to integrate. This is basically 3x to the -2 plus 1 over -2 plus 1 minus log x plus c. I'm going to do the cleanup. So this is 3x to the -1 over -1 minus log x plus c. I did the integral here, so I'm just cleaning up. So this will become -3 over x. X to the -1 comes down with a positive exponent minus log x plus c. Remember, ln of x is basically log base e of x. We call it the natural logarithm, and that's why I call it log. I don't say ln because it's a logarithm function. So that will be the final answer for the integration. Let's see if we can do another example. Okay, in this example, we want to integrate an exponential function. So to integrate an exponential function, we're going to follow the exponential function rule. I'm going to use the general rule. If we have integration of e to the ax dx, whether there is a b here or there is no b here, then the integration is the b out, and then we divide by the coefficient of the exponent of the exponential function. We keep the exponential function as it is, and then we add a constant. So that is the general rule that we're going to follow right here. So to do the first one, number 1, this is 3 out integral of e to the x dx. So this is basically 3, and then we're going to follow the rules over 1, the coefficient of the exponent, e to the 1x plus c, which is basically 3e to the x plus c. If you differentiate this, you're going to get back this integrand. Number 2, we're going to follow the same thing. So -4 comes out. We want to find integral of e to the 4x dx, -4 out, and we have to divide by the coefficient of the exponent of the exponential function, which is 4, keep the exponential function as it is, and then add a constant. To simplify this, this becomes -1 e to the 4x plus c. And that will be the final answer. If you differentiate this function, you're going to get back the integrand. You're going to get back the integrand. So the 4 will come down and then keep you the exponential function as it is. And then the derivative of the constant is 0. And finally, quickly, I'm going to explain this application. Sales records at JRS Technology show that the rates of change of the revenue, that is the marginal revenue in dollars per unit for motherboards, is the marginal revenue is equal to 300 minus 0.2x, where x represents the quantity sold. Find the total revenue function for the product, then find the total revenue from the sales of 1,000 motherboards. In this case, we have the marginal revenue function. We know that we found the marginal revenue function by differentiating the total revenue function. That means if we integrate the marginal revenue, we're going to get back our revenue function, and that's how we're going to get it, because we want the revenue function in that case. So here we want to find the revenue function, which is the integration of the marginal revenue function. Integrate each one individually, so you will get the final answer, 300x minus 0.1x to the second plus c. Now, in order to find the constant c, because that constant c, we don't know what it is, but we still know some information that can lead us to the value of that constant. We know that there is no revenue if we don't sell any units. So the revenue is 0 if we sell 0 units, which is the x. So I substitute x with 0 and the revenue with 0 and solve for c. In this case, I have c is equal to 0. In other cases, you could have a different value for the constant. So I will conclude that this c is actually a 0 and the revenue function is just 300x minus 0.1x squared. Now we want to find the total revenue from the sales of 1,000 motherboards. So all we need to do is replace X with 1,000 and solve, and the answer is going to be $200,000. I hope this video helped you understand integrals and how to integrate those functions. Please keep practicing, do your homework, and if you have questions, let me know. And I'll see you in a different video.